Solve systems by substitution. So last week we looked at systems or two equations where we graphed the lines, and where the lines overlapped, that point was the solution. So now we're going to look at no graph, just the equations, and we're going to figure out what the solution is. Remember, the solution is an ordered pair, and in order for it to be an ordered pair, you have parentheses, an x value, comma, and a y value. So we're solving for the x and y in a system. So my first problem, our first example, here are my two equations. Y equals 2x minus 8 and y equals 4. Well, when they give you one of these equations where it tells you x equals a number or y equals a number, they're actually giving you half of the answer. And this one, the half that they're giving you is telling you that the y number is 4. So you're already halfway done when that happens. So you start your ordered pair or your answer, put 4 in place of y. That's when it's just y equals a number. Alright, here's where the substitution comes in. I got to now figure out what x is. So in the other equation, I'm going to take this 4 and substitute it in place of y, because that's what it tells me y is. So here's what I would write. 4 equals 2x minus 8. And I have to solve that for x. I need to get x alone. So first of all, I'm going to add 8 to both sides. 12 equals 2x, because these 8's will then fall out. And the last step is to divide by 2. So x equals 6. So my answer to this problem, my ordered pair, is 6, 4. And now we're going to move on to example 2. So this one has a little bit more involved in it. So this example is y equals 2x plus 1. And the other equation is 3x plus y equals negative 9. Okay, so there's not any of this x equals a number, y equals a number, so I really don't know what it is. I have to solve for both of them, so I got my answers started there. I just got to fill them in. So substitution means that I'm going to take what y equals, which is 2x plus 1, and substitute it in the other equation in place of that y. So what I would have then is 3x plus, and for y I'm going to put 2x plus 1 equals negative 9. So to solve this for x, I've got to combine my two like terms, 3x plus 2x, 5x plus 1 equals negative 9. And now I need to solve to get x alone. So I'm going to subtract 1 from each side. And 5x equals negative 10. Divide by 5. X is negative 2. So now I can fill in half of my answer that x is negative 2. Not quite done though. I've got to figure out the y that matches that negative 2 for x. So another substitution comes into play. I'm going to take that, I'm going to bring it all the way up here. So it would be y equals 2 times negative 2, I've substituted that in, plus 1. And now I need to solve that. So 2 times negative 2 is negative 4 plus 1. So y is negative 3. So my intersection point is negative 2, negative 3. Questions about that? Okay, third example. This one, the first equation is x plus 4y equals 33. And the second, y equals negative 3x. So again, it doesn't come out and say x equals a number or y equals a number, so we don't know for sure. So I'm going to substitute though because I know y equals negative 3x. So I'm going to plug that in right there for y. And this is what that would look like. X plus 4 times negative 3x equals 33. So x, 4 times negative 3x is negative 12x equals 33. X minus 12x is negative 11x. And divide by negative 11. So x would be negative 3. And I would go plug that in up here. And then one more substitution where I take this value for x and plug it into this equation. So y equals negative 3 times negative 3. So y equals 9. And that would be the value you'd plug in here. Okay, so you're solving for that. Now I just want to remind you of some things. If the variables would fall out when you start plugging one in for another, if the variables would fall out, let me show you one like that. Let's say we had y equals 2x plus 3, and let's do one like y equals 2x. So if I had to do this, I would definitely substitute this in here for y. And then it would be 2x equals 2x plus 3. And I would need to bring my x's together to solve. So I'd have to subtract 2x from both sides, but what happens on both sides is that makes all of this fall out. So the left would be 0, and the right would be 3. So when the variables fall out and the numbers are not equal, 0 is not equal to 3, your solution is basically no solution or empty set. Okay, if the numbers fall out, if the variables fall out, and the numbers are equal, so let's say it said 3 equals 3. That's the ones where you say IMS. Who can tell me what IMS stands for? We talked about it the other day when we were graphing. Infinitely many solutions. So if they fall out and they're not equal, like this one, you say empty set. If they are equal, let's say 3 equals 3, you would say IMS. Either way, you're substituting in and you're solving for an x value and a y value to give the answer as an ordered pair.